Hello, this is Dong-Soo from the Applied Superconductivity Lab. Today we will learn about the thermal expansion coefficient. The main concepts of the lecture are linear thermal expansion in the superconductor or thermal shock of the superconductor, and the table for the coefficients of thermal expansion about different materials. First, linear thermal expansion is the tendency of a material to change its volume or length in response to a change in temperature. The representative examples are rail deformation because of the thermal expansion in the rail, and the thermal expansion joints in bridges to prevent the deformation. The coefficient of thermal expansion is included in the equation, which is the rate at which a material expands in response to the temperature change. Next, this example shows the thermal expansion in a superconductor. From the example, a composite superconducting wire goes through the heat treatment of 1000 Kelvin and then cools down to 4 Kelvin to operate the superconducting wire. Using the linear thermal expansion equation in the previous slide, we can solve for the change in the niobium-3 tin and copper length by applying the given thermal expansion coefficient for each material. However, a temperature drop from 1000 Kelvin to 4 Kelvin is a drastic temperature change, which may cause a thermal shock. Thermal shock occurs when a sudden or drastic temperature drops in a specific local area using cryogenic liquids or gases. Due to relative thermal expansion, mechanical damage within the superconductor can occur. For example, in the case of superconducting magnets, a quench can occur, where a sudden increase in temperature causes a localized thermal shock. Similarly, heating can occur where SUS, stainless steel, Rebco or rare earth barium copper oxide wires are bonded with epoxy in a specific area. While the stainless steel contracts due to thermal contraction, the Rebco wire bonded with epoxy remains relatively stationary. As a result, the epoxy expands, causing delamination as it separates from the Rebco wire. This table shows a portion of the coefficient of linear thermal expansion CT. It has approximate CTE ranges for different materials and helps calculate linear thermal expansion. In this lecture, we have covered that the thermal expansion coefficient is a linear parameter where the rate at which the volume or length of the material changes in response to changing temperatures. Also, calculating the thermal expansion coefficient is crucial in the superconductor because of its thermal shock after the heat treatment process, which may result in coil delamination.